Hello everyone, welcome to this video. In this video, let's have a look at this question. They are saying in each case we need to perform the indicated operation. So here in the first part, the group that is given to us is this C star, which is the group of non-zero complex numbers, and the operation is multiplication, you know that. So here in the first part we need to solve in C star, we need to perform this multiplication 7 plus 5 iota multiplied together with minus 3 plus 2 iota. Now this is very simple. We already know how to calculate two complex numbers, multiply two complex numbers. So this first element is multiplied with the first element here, it is minus 21. Then the first element is multiplied to the second element here, which is plus 14 iota. Then the second element is multiplied to the first element here, which is minus 15 iota, and the second element is multiplied to the second element here, which is what? It comes out to be minus 10, right? Because iota square is minus 1. So you can take the like terms together, it would come out to be minus 31 minus iota, and this is what is your answer for the first part. For the second part, they are asking you in this general linear group of all 2 cross 2 matrices, and the group here is given to be Z13, right? So here addition modulo 13 and of the integers, we need to determine what is the determinant here. So let's solve for the determinant here. So we are given GL2 comma Z13, right? So we are to calculate the determinant of 7, 4, 1 and 5. So what would be the determinant? You can very easily compute its determinant. So you know how to calculate the determinant in usual sense. It is 7 into 5 minus 4 into 1, right? So what is the value? It is 35 minus 4, which is equal to 31. But because we are in Z13, we wanted to calculate it under mod 13. So when you divide 31 by 13, you would have the answer as equal to 5, right? So this would be equivalent to 5 mod 13. So 5 is the answer. 5 is the determinant in this particular case, right? Let's move on to the third part here. For the third part, they are saying in the general linear group of all 2 cross 2 matrices whose entries are being taken from the set of real numbers, we wanted to calculate the inverse of this particular matrix. So let's do that. So in the C part, we are in the group general linear group of all 2 cross 2 matrices in the set of real numbers, and we wanted to determine what is 6, 3, 8, 2 inverse. So first of all, let's name this matrix. Let A is equal to 6, 3, 8, 2, right? So first of all, what is the formula to calculate the inverse of A? It is adjoint of A, right, divided by the determinant of A. This is the formula. So let's first of all calculate the determinant of A. What is it? Determinant of A is the determinant of this matrix, right? So it is 6 into 2 minus 8 into 3, which is 12 minus 24, which is minus 12. So minus 12 is the determinant. Now in order to calculate the adjoint of A, what is the adjoint of A? It is the transpose of the cofactor matrix, right? Cofactor matrix. It is the transpose of this cofactor matrix. What is this cofactor matrix? First of all, let's calculate it, right? This is our matrix. So 2 would come here, 6 would go there because they would exchange places, and here we have the plus sign, here we would have the minus sign, and both of them will exchange the places. So here we would have 8, here we would have 3, right? This is your cofactor matrix. Now in order to calculate the adjoint, we need to take the transpose of it, which is 2 minus 3 minus 8 and 6, right? This is the adjoint A. Now you have both the quantities. So what is the inverse of A? Inverse of A is adjoint of A divided by the determinant of A. The determinant of A is minus 1 by 12. Adjoint of A is what? We have just evaluated it. This is 2 minus 3 minus 8 and 6, right? So you can multiply the things inside, so that you would have minus 1 by 6 here, 1 by 4 here, 2 by 3 here, minus 1 by 2 here. So this is the inverse of A. Further, you can verify that whether this is inverse, correct inverse or not. So let's verify what is A inverse. So from here, you know what is your A. The matrix A was given to be 6, 3, 8 and 2. 6, 3, 8 and 2. And A inverse, we have just evaluated this to be equal to minus 1 by 6, 1 by 4, 2 by 3, minus 1 by 2. Right? So you can multiply them together so that you would have minus 1 plus 2 here. Then it would be 3 by 2 minus 3 by 2 here. It would be minus 4 by 3 plus 4 by 3 here, 2 minus 1 here. So that it would come out to be 1, 0, 0, 1, which is nothing but the identity matrix. Hence, we have verified that we have calculated our inverse as the correct inverse, right? This is about the C part. What about the D part? Now we are in general linear group of all 2 cross 2 matrices whose entries are being taken from Z13, correct? So here in Z13 we have to calculate the inverse. Now this is quite different from the C part because here our group has been changed from the group of real numbers to the group of Z13. So let's compute it. What will be the value for the D part? We are in GL2, Z13, right? And let A is equal to 6, 3, 8 and 2, right? So we first of all compute the determinant of A. The determinant of A would be calculating the determinant of 6, 3, 8 and 2. So its determinant would be equal to 12 minus 24, which is minus 12. Now because we are in what? We are in Z13, so we have to compute it mod 13. So minus 12 plus 13, it would give you plus 1. So it would be equal to what? It would be equal to 1, right? So this is the determinant here. So, and moreover, because we know A inverse would be given by determinant of A inverse multiplied with the adjoint of A, right? So therefore, let's mark this as equation 1. We first of all compute what is the inverse of the determinant that we have found. We have found the element to be 1. So basically, for calculating inverse, we are looking for some element here, say x, such that it is equal to 1 under mod 13. So can you have some element here? You know, in Z13 we have all the elements because we are having the operation as multiplication mod 13. So we have all the elements starting from 2 up to 13, correct? So these are the elements. So for these elements here, you can see your x comes out to be 1, because if you have 1 into 1 is 1, which is 1 mod 13. So x is 1. So basically determinant of A inverse is also equal to 1, right? Now we wanted to compute the adjoint of A. In order to compute adjoint, let's first of all compute the cofactor matrix. So what is the cofactor matrix? Cofactor matrix of A, it would be calculated in a similar fashion. You just exchange these two together so that it would be 2 and 6, and you put a minus sign here and exchange them together. So it would be minus 8 and minus 3, but we have to do it under mod 13 so that now we have to change minus 8 and minus 13. So you can see you have minus 8 plus 13 as equal to how much? It is equal to 5, right? And you have another thing, minus 3 plus 13, it is equal to plus 10. So instead of minus 8 we are writing 5 here, right? And instead of minus 3 we are writing 10 here, right? All the others, they are the same. So this is our cofactor matrix. Now once we have the cofactor matrix, the adjoint matrix A is nothing but the transpose of cofactor matrix, right? And you can very easily compute the transpose of 2, 5, 10, 6, right? It is equal to 2, 10, 5 and 6. So this is your adjoint of A. Now once you have adjoint of A, you can very easily compute the inverse. It is determinant of A inverse multiplied together with adjoint of A, right? So what is the inverse of determinant A inverse? It is just equal to 1 multiplied with this matrix 2, 10, 5 and 6. So your matrix is how much? It is the same matrix as your adjoint A. So I say this is A inverse. So again, in this case also, let's verify the results. So let's compute what is A inverse. So remember, we were given the matrix A as 6, 3, 8 and 2. Let's multiply it together with 2, 10, 5 and 6, right? When you compute this, and we are doing this calculation under mod how much? 13, right? So when you compute this multiplication, you would have the numbers as 27, 78, 26 and 92, right? But we are doing this calculation under mod 13, so that when you compute mod 13 of 27, it would come out to be 1. When you compute mod 13 of 78, it would be 0. Mod 13 of 26, it would again be 0, and mod 13 of 92, it would be 1, which is nothing but the identity matrix. Hence, in this case, we would have A inverse as equal to identity. Hence, we have our result verified, and this is your answer. So I hope you understood how to perform such kind of calculations. Well, that is it for this video. Thank you for watching.